Hello everyone, welcome back to मैथमेटिका आईएएस। हम सोल्व करेंगे 65th बिहार पीसीएस मेंस एग्जामिनेशन मैथमेटिक्स ऑप्शनल पेपर। So let us start with first A question. It says that let W be a subspace of an n-dimensional vector space V, then show that dimension W is less than equal to n. That is, dimension of W is less than equal to dimension of V, that we need to prove. And second part is says that in particular if dimension of W is equal to n, that means dimension of W is equal to dimension of V, then show that W is equal to V. So let us start the solution proof. So it is given that V is a finite dimensional vector space and dimension of V is equal to n. And what we need to prove that claim is dimension of W is less than equal to n. So first of all we need to prove that W is a finite dimensional subspace, and second part we need to prove that dimension of W is actually less than equal to n. So first part we will prove by method of contradiction. Let us assume that W is an infinite dimensional vector space. Infinite dimensional subspace. So every vector space or subspace has a basis. That means let S be a infinite basis of W. That means S has infinite number of linearly independent vectors in W. So these infinite linearly independent vector will be linearly independent in V also. That we can separately prove that if a set of vectors is linearly independent in subspace W, then that will be linearly independent in vector space V also. So to prove that, let us assume that V1, V2 and Vt be a set of linearly independent vectors in W. So what we need to prove that these vectors are linearly independent in V also. So to prove that, let alpha 1, alpha 2, alpha t belongs to field F, and combination alpha 1 V1 plus alpha 2 V2 plus dot 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 alpha t Vt is equal to 0 in V. Since V1, V2, V3 belongs to V and these are linearly independent in W, that means VI's belongs to W also, and these are linearly independent in W, that means alpha I is equal to 0 for all I. That shows that VI's are Li, that is linearly independent in V. So we have proved that S is linearly independent. That means a set which is linearly independent in W will be linearly independent in V also. That means S is linearly independent in V. So S has infinite number of elements, and these elements will be part of basis of V. That means basis of V has basis of V has infinite number of elements, which shows that dimension of V is infinite, which is contradiction to given statement that dimension of V is finite, that is n. That means our assumption that W is infinite dimensional vector space is incorrect, which imply that W is a finite dimensional vector space, finite dimensional subspace of V. So first part we proved, and second part we need to prove that dimension of W is less than equal to n. Since W is a subspace of V and W is finite dimensional, let us assume that dimension of W is equal to m. That means S1 be a basis. Let S1 be a basis of W, and S1 contains m elements. So S1 is a subset of V also, because S1 is a subset of W and W is a subspace of V. So S1 is a subset of V. So S1 is a linearly independent subset of V. So from the extension theorem, we can say that S1 can be extended to the basis of V, which means if we add some more linearly independent elements in S1, it will become a basis, some Li vector. It will become basis of V. That means S1 plus something will make the basis of V. Hence S1 has lesser number of elements than basis of V. That means cardinality of S1 is less than equal to n. That means dimension of W, that is equal to cardinality of basis S1 is less than equal to n. So we have proved that dimension of W is less than n. Now second part of question says that in particular, if dimension of W is equal to n, then show that W is equal to V. So dimension of W is equal to n. It is given and we need to prove that W is equal to V. So let S1 be a basis of W and dimension of W is n. That means S1 will have n elements and elements of S1 are linearly independent in W, and W is a subspace of V. That means elements of S1 are linearly independent in V also. So it shows that S1, a set of n vectors, is linearly independent in V, which imply that this is a set of linearly independent vectors which in number are n, which is equal to dimension of V. That means S1 is a basis of V also. Hence linear span of S1 is equal to V. And since S1 is a basis of W, in the beginning we have assumed that S1 be a basis of W. That means linear span of S1 is W also. which shows that W is equal to V. Thank you guys. Thank you very much. You can join Telegram group whose link is mentioned in the description, and also subscribe and like the video if you like the answer and explanation which I have given in this video. Thank you very much.